clean text, you can see. So this was the flow that we have discussed, tokenization. We took the text, we tokenize it. After that, we remove the stop words. Then we perform stemming. Stemming or lemmatization, it's your choice. Vectorization. For vectorization, we have discussed this particular model, bag of words model. And after that, we perform the model train. So we did bag of words model. We applied all the concept over here on bag of words model. So this is what we have taken, and based on this, we had a discussion. How does it work? And we took this particular data set. This data set was about fake news. So we have one feature called text and one feature called label. So text is the independent feature. Based on this text, we have to predict the news is fake or not. So if it is fake, it's 1. If it is genuine, it is 2. Alright? Fake, not fake. Just like that. And for the time being, there were 20,000 plus rows, but I have taken only 1,000. And I ask you to do it on your own, right? To take 20,000 the whole data, you can skip this line of code and you can try. Why I have taken only 1,000 lines over there? Because when we tried this pipeline means what? Cleaning of the text over here. The cleaning text we tried. So when we were having this much long text, when we applied it over here it took a lot of time. Now here you can see like around 1 minute it took on Colab to just clean the text over here for only those 800 something rows. After removal of the null values and all, we got only 800 something rows. For that it took 1 minute. Now we were having 20,000 plus, right? So it may take 15 to 20 minutes to complete. So I don't want to waste the time, but I would recommend you to go through it, have patience, let it take the time, but you will get something better than me, whatever the model I'm getting. If you're going to give more data to the model will learn better. All right. So we applied this technique, bag of words model. I'll come to that thing, Kush. Let me just complete few things over here. We'll come back to it. Okay, which model is used in vectorization in current time? Okay, if you talk about current time, people do use TF-IDF vectorizer that we are going to discuss. But nowadays, when you will be having, I hope you have GenAI also in the discussion. GenAI is there, yes or no? You have GenAI, right? After in your internship. I'm talking about in your internship. I hope all of you have gone through all the things. Do you have GenAI? Yes, right? So Hertz basically, when it comes to embedding models, so there are plenty of embedding models in the market. So those things will be discussed when you will be starting with GenAI. So there is a library called Hugging Face. From Hugging Face, we can use a lot of embedding models. Directly you can use and you can download and you can use. Okay. So what we did, we changed the data in numerical form. That is, we performed the vectorization and we stored it in the data frame. We removed the unnecessary features. We had the clean data set, and once it was done, what we did, we splitted the data into train and test. We trained the model, naive-based model, multinomial NB, that is multinomial naive-based. And once we trained it, and we got around 85% of the accuracy. That is good. Now you can go to improve it, but as of now, we are considering 85% is there. The next thing that we were about to discuss was TF-IDF. So this was pending. Once it is discussed, we'll move to the next topic, that is going to be deep learning. We'll be just starting the session about deep learning today. Bits and bytes. Alright, so TF-IDF vectorizer. Let me just go back to this Scrubber link again, and if you remember, we were using this reviews. By taking this reviews only, we'll discuss what exactly the things need to be done. Okay. So let me do one thing. I'm going to remove the stop words. What are the stop words, guys? This is the stop word. This got removed, right? This got removed. Here is very is also stop word. And is also stop word. Not and is. Yes, I'm getting the right answers in the chat. Okay, I'm glad you remember all the things. Perfect. So what I need to do over here, I need to create a vocab. I'm creating a vocab. Vocab is nothing but set of or collection of unique words used in the corpus. So this is our corpus, right? The whole corpus. We are going to create a vocab. So in vocab, we are going to put all the things in alphabetical order. So first is going to be good. Then we have good. Then we have long, right? Then what we have? Let me do one thing. I will give some space over here. I will be writing the formula. Let me start from here. The vocab. So we have good. After good, we have to go alphabetically, not moving us. A, B, C, D, E, F, G, H, I, J, K, L. L means what? Long over here. Long. L, M. Then what we have? We have scary. Scary. Then what we have? Spooky. Sorry, scary, slow, and at the end we have spooky. I think I have covered all the things. Fine. Now here let's try to understand how does TF-IDF works. TF-IDF vectorizer. TF-IDF vectorizer. So I'm just going to copy some text from here. Don't want to waste your time. I'll just copy this thing. Term frequency. TF is term frequency. So I'm just going to put it over here. We have term frequency. Alright. Now let me put IDF also. Okay. TF will be calculated. Let me calculate TF first of all, then we'll put IDF. So how we are going to calculate TF? TF is nothing but number of repetition of words in a sentence, how many times that word is repeating in the sentence, and number of word in the sentence. Number of word in the sentence. So as of now we have removed this particular thing. We have removed this particular what we can say stop words. So as of now 1, 2, 3, 1, 2, 3, 1, 2, 3. All the sentences are having 3 words. Now we have to mention number of repetition of word in a sentence. So how many times that word is getting repeated? So review 1, review 2, review 3. Now here good is 0 by 3. So 0 by 3 is 0. Long. So number of repetition, 1 time is getting repeated. If it is getting 2 times repeated, we will write 2. Number of word in the sentence, 3, 1 by 3. Movie is also 1 by 3. Scary is 1 by 3. Slow is not there, then 0. Spooky is not there, then 0. In review 2, again, long is also not there. What we have movie, how many words? 3 words by 3. Scary is there, slow is there, and spooky is not there. Now here, good we have 1 by 3. Then what we have? We will be having long. Long is not there. Movie is there. 3 words. Scary. Scary is not there. Slow is not there. Spooky we have. Okay. Now what we have taken? We have taken term frequency. We have taken what? Term frequency. Now once you have got that term frequency, I am not audible. Hetakshi is saying I'm not audible. Guys, can you please confirm? Am I audible? Loud and clear? Audible. I'm audible, Hetakshi. Let me just type it over here. I think she is not able to hear me, so let me type it. All right. So we have calculated term frequency, and the next thing that we are going to calculate IDF. IDF stands for inverse document frequency. Inverse document frequency is going to be nothing but you can say a single line array. I'm just going to paste it over here. Let me just take it a little down. Fine. Now guys, okay, let me just remove it from here. I think it would good if I'm going to put it above only, so that, just a second. Yes, let me keep it above. Fine. Now this particular thing that we have calculated as of now, this is TL. This is TL. Now we are going to calculate IDF. We are going to calculate IDF. How 3 is in the dominator? Review has 7 words. Very good question. Now review has 7 words, but these are the stop words. We have removed the stop words, right? If you have removed the stop words, then how it is 7? If you're not removing the stop word, then it is 7. Okay? Fine. Now just look at the formula over here that we have for IDF. Now we will be calculating the IDF for each vocab. So each word in the vocab. So, sir, in vocab there are 6 words. Look, it is saying number of repetition of the word in a sentence, a particular sentence, and number of word in the sentence, by the number of word in a sentence. In vocab we have 6 words, but here we are talking about the sentence. Can you see sentence? We are talking about sentence. Sentence, not vocab. A particular sentence. When I say sentence, this review 1, review 2, review 3, 1 by 1. Alright. Perfect. Okay. Now let's calculate IDF now. How the IDF is going to calculate? So here I'm not going to see you the whole calculation because it is going to be a bit complex for me as well to show you the entire calculation. But here you will get some idea. So in IDF is nothing but log of number of sentence by number of sentence containing the word. Okay, number of sentence. Here I am going to calculate IDF for all the words. Here only I am calculating for good. Number of sentence. So we are taking log. Log of number of sentence 3 by the number of sentence containing the word. So that is 3 by 1. Only one sentence it is having. Right? Let me me just put one thing our place. Fine. Now what we have? Long. In how many sentences we have long? Log of number of sentences, that is 3, by number of sentences containing the word. So log we can see only in 1. So that is 3 by 1. Alright. Now movie. Movie, number of sentences is 3 and movie is there in all the particular sentences, that is 3 by 3. Okay. I am going to ask you a very simple mathematics question here, guys. Log 3 by 3, if I am going to take, it is equal to log 1. What is log 1 equal to? If you remember school mathematics, very good, very good. Log 1 is 0, not 1, it is 0. Yes, I am getting right answers from everyone. So what we can say over here, if a particular word is getting repeated in all the words, then it is going to be considered as 0. If it is there in the whole, all the sentences, then it is going to be 0. Fine. What about scary? Now if you are going to see scary is a bit different over here. So for scary we will be taking, okay, let me just take you, it is going to be 0. Log. Scary, if you are going to find, number of sentences are 3, but scary is there in 2 sentences, right? In 2 sentences we have scary, in review 1 and review 2. Slow again, log 3 by 1, right? Slow is only at one place. Spooky, again, log 3 by 1. Now what we have got, this particular array, and we have got this particular array. We have got TF, we have got IDF. What we used to do, what exactly TF IDF vectorizer is about? TF, let me just use a different color. It is going to be nothing but TF into IDF. So this particular array will get multiplied with this particular array. Then what you will be getting? You will be getting a vectorized array. A vectorized text will get converted into vectors. I hope it is clear how TF-IDF vectorizer work. Sorry, I am not going to show you the each calculation over here like the way I showed you already for bag of words, because it is going to be lengthy, guys. If I am going to sit and calculate all the things, matrix calculation, how lengthy it is going to be. So I'm just going to come over here and I'm going to import this particular module. So from same feature extraction.text, we will be importing TF-IDF vectorizer. We'll be creating one object of this class. We'll ask this particular object to fit and transform the corpus that we already have. Okay, above. Corpus, from where we got the corpus? If you remember, here we have got the corpus. So this is our corpus, right? This is the corpus. Corpus is having the clean text. So on this clean text, we are going to apply TF-IDF vectorizer and we will be getting one array. Now one thing if you remember, we haven't given the number of columns we want, right? In bag of words we have given maximum columns. Here we have not given. So what exactly you will be getting? You will be getting the number of columns based on the unique number of words or the total words you have, the number of words in vocab, the unique words. Okay, so how does our one single vector look like? It looks like this. Now if you are going to see, what was the difference between bag of words and here? So bag of words was very simple. It was just counting the number of occurrences. But sometimes it is not efficient. Now here if I am getting a different value for different words, or 0 for the word those who are getting repeated again and again. So here I am assigning some weightage. I am assigning some weightage over here. So once it is done, we are going to concat it with the data frame that we have. Let's concat it. Done. Now if you are going to see the shape guys over here, the shape is you are having 870 rows and 23,000 plus features. Now let's see, let's drop unwanted features over here, that is ID, title, author and text. And this is our final data frame. So our data frame is having 23,439 columns, out of which one label is there, that is one target feature, and others are nothing but independent features. What we'll do, we will simply split the data into train and test. We will try with multinomial NB again. Let's try with multinomial NB. Model got trained. We'll ask the model to predict the test data. Model has predicted the test data. We'll see the confusion report. Sorry, classification report. Classification report is not defined. Okay, let me just run the code above that I had. Okay. Let me run the things from here. So when we try bag of words model, we were getting 85% over here. Let's try with this one. No, here I need to do one thing. I need to use this one over here for train and test. Yes. We'll train the model again. This time you will find different. So here the accuracy got dropped. Now why the accuracy got dropped? We have to think from the different perspective. Multinomial NB, it works when you are having the distribution that is some sort of multinomial distribution. Multinomial distribution we were having when we were having the discrete numbers, right? So bag of words model was producing discrete numbers, like 1, 2, 3 and all, and that time if you are going to plot it, it is going to be multinomial. So here multinomial will not work well. We'll try something else. So okay, heat map, let me import SNS. Import the bond as SNS. Fine. So model is working perfectly for one particular data. So you can see 0 is getting predicted 0 time as 1. That means all the predictions are true for 0. But here you can see it got biased a lot. 1 is predicted as 0 so many times. For 1, model is not running well. It is not balanced. So here we will try Gaussian NB. So Gaussian NB will be used when you are expecting that you have normal distribution in the features, independent features. We'll train the model again. Now we'll see the classification report again. So this time we have got 78% accuracy, but it is balanced. It is balanced accuracy. Now we can work more on this, and the accuracy may improve when we are going to increase the number of features that we have, not features, the number of rows we have. As of now, I have used only 870 rows, but you can use more. So this was TF and IDF vectorizer, guys, and what are the different type of neighbors I have mentioned over here for your reference. Clear till here, everyone? Sir, can you repeat IDF one more time? Sure, I'll repeat IDF one more time. Let me come back. So IDF stands for inverse document frequency. How does it work? It takes the log of number of sentence by the number of sentence containing the word. Now, if you talk about good, and if you're going to see the review, good is only there in only one sentence, right? So what is the number of sentence? Number of sentence is 3. I took 3, right? Number of sentence containing the word, only 1. That was same for long. For movie, what we have seen, number of sentence is 3. Number of sentence containing the word 3. So that is 3 by 3, 1. Log 1 is nothing but 0. So the particular word that is getting repeated in all the in all the sentences, so we will consider 0 for it. And scary, if you see scary is there in review 1, and scary is also there in review 2. So 2, number of sentence is 3, and number of sentence containing the word is 2. Yes, exactly, Raj. And finally, what will happen? TF will get multiplied with IDF. Now, I hope you know matrix multiplication. So I won't be able to show you all these things getting multiplied because it will take a lot of time. I'm assuming you know matrix multiplication. Okay. For simple mathematics things, I can rely on you. If I am going to teach all the mathematics from the scratch, and concept NLP pipelines that we have discussed. So I have discussed only 2 vectorization method, that is backup words, TF-IDF vectorizer, and there are a lot more. Okay, there are a lot more. So here we are just trying to understand the concept, what exactly we do in an NLP project. We got the text. The text is nothing but the corpus. We are going to tokenize it first of all. Tokenizing is what? We are going to break it down into different chunks. Once chunks are created, so we are going to remove the stop words. Stop words means what? The unusual words, the words that we don't require in our data set. And after that, we perform normalization of the words, either with stemming or lemmatization. So once it is done, we will be getting a clean text. We are doing the pre-processing of the text. So the first level was cleaning the text. Once the cleaning of the text is done, we'll go to the level 2 of text processing. That is going to be converting the text to vectors. Once you are able to vectorize your data, you are ready to give the data to the model to get done. And again, you have to create the pipeline. Let's suppose you have deployed this particular model. Now again, model only understands what? Model only understands vectors. So whenever you're going to give a new text for the prediction, what you need to do, you need to create the same pipeline. So if user is going to enter the text, it should create the vectors of the same shape, the shape that you have given. Here the shape I have given 23,000 plus, so the same shape you have to give for independent features, the vectors. Even a user is going to enter high, it will go like this. Alright? Can we move ahead, everyone? Clear till here? Can I get quick yes, thumbs up from everyone? Nice. Perfect. Okay, now what we are going to do, we are going to discuss about the concept of deep learning right now. And I think few of the things was already discussed about machine learning. I hope you are clear with the machine learning concept. So I'll give you a quick overview why deep learning is required, what exactly deep learning is, why we are using it, and all the system. Fine. So first of all, okay, we will be starting our session on deep learning. Let me just keep this thing. Chat window I'm having, so I'm just fixing the chat window. Fine. Machine learning was there. Now we have deep learning. Okay, now to understand deep learning, here I will go with that bubble. I think all of you have already seen this bubble. You have a bubble, and this bubble is nothing but A. Now inside AI, what we will be having? We will be having one subset, and this subset we call it as, just a second, let me just fix the size of this subset. This subset we call it as machine learning. So machine learning is nothing but subset of A. Machine learning is subset of A. Now subset of machine learning, we are going to call it as deep learning. Okay, we will be calling it as deep learning, DN. Let me just correct this thing. ML. Subset of deep learning that we have, subset of deep learning is nothing but we call it as GenAI. GenAI, generative AI. And if you're talking about NLP, where NLP is here, common in all, NLP, natural language processing. Okay, NLP and all we have already discussed. Now NLP is nothing but a process that we were using to clean the text and make the text in model ready, simply to make the text model ready. Okay, what exactly AI is? I hope it is already discussed in the first session only what exactly AI is. I don't need to discuss. But in short, I'm giving you a quick revision. Look, AI is made up of two words, artificial and intelligent. Artificial means man-made. What is intelligence? Okay, how many of you think that you are intelligent? You can type me or I'm intelligent. Alright, Jit thinks he is intelligent. Anurag, why don't you think Jay? Okay, we have to be confident. So those who are saying no, or not me, I'll tell you. What exactly intelligence is? Intelligence is nothing but the ability to learn a skill and apply that skill. Acquiring a skill and applying is the skill. If I'm going to show you how to make paper aeroplane, you will be able to make your own paper aeroplane just by watching me making a paper aeroplane. That means you have the ability to learn a skill and apply that skill. Okay? So intelligence is nothing but the ability. Now, if I'm talking about artificial intelligence, that means the ability that we are making it artificially, like man is making the ability. And if we talk about the intelligence, here we're talking about the human intelligence. What is our intelligence? Our intelligence is making the decision, identifying the difference between good or bad, the objects, this is cat, this is dog, this is laptop, this is desktop, right? We can identify colors. This is our intelligence. And when we go to the market to buy fruits, what type of fruits you will buy. You will buy only good fruits. That means you know, you have that intelligence. You have that intelligence to differentiate between good food and good bad food. Like if I'm going to ask you to bring, or if you're intelligence is coming from, how you got that much intelligence that you are able to identify the difference between good and bad fruits. I'm talking about only fruits right now. How you got this intelligence? Can anyone tell me? By observation. Very good. Manish is saying observation. What about others? Mandate task. Okay. Viral. What about others? From label data? No. What I was asking, Sahil, how you are becoming that much intelligence? How you got that intelligence level that you are efficient in finding the roots and back? Okay, a few things I'm getting. Atharva is saying experience of observation. Very good. Touch. Okay, learning a pattern. Very good, Raj. By learning features. Okay. By copying. Practice. Okay, one of the very good term used by Darshan, practice. By learning features of bad fruits and good fruits. Now, let me tell you what happened. Let's suppose 1 year ago, you to go to the market and bring 1 kg of apple. You went to the shop, you asked that fruit wala, that shop owner, give me 1 kg of orange. He picked on his own, he given to you, and you took it to your home. After reaching home, what moms identified, half of the apples are not good. Half of the apples are not good. And mom is going to tell you, this is what you have, brought. Half of the apples are not good. Now, there you will understand, okay, if an apple is having this type of particular features, if this type of spots are there, holes are there, you should not buy those type of apples. Right? So, from the past experience, we are learning from the past experience. The same experience we are giving to the machine. Right? That is artificial intelligence. Now, how we achieve artificial intelligence? We achieve artificial intelligence with the help of ML or DeepL. Okay? In industry, everything is machine learning. Everything is machine learning. You will not get any, a job role with the name deep learning engineer. You will find machine learning engineer because everything comes under machine learning. Yes, you will be getting GenA engineer, Agentica engineer nowadays. Previously, there used to be a role NLP data scientist. Okay, purely they used to work on a text problem. So here, we have already done lot of things on machine learning. Now we are starting deep learning. What is the main difference of it? With the help of AI, what we try to do, guys, we try to mimic human behavior. What is our behavior? With deep learning, what we try to do, we try to mimic human brain. We try to mimic human brain. Okay. Now, why there is a requirement of mimicking human brain? Let's try to understand. The basic difference between machine learning and deep learning is going to be, so guys, when you talk about ML works on whatever you have used so far. You have used structured data. Okay? Structured data. What does structured data means? The data that you are getting in the form of tables, tabular form of the data. So all the ML techniques will work on structured type of data. Structured data means what? You have Excel file, you have CSV file, you have data in any database, right? Table, any DB. So RDBMS you can say. So here we will be having the structured data. Now deep learning can work on structured data as well as unstructured data. So basically, when we are facing a problem where we have to deal with unstructured data, the data that we can't put into rows and columns, that time we will be going with deep learning. Okay, can you give me an example of unstructured data? Anyone? Unstructured data? Okay, Google search, book. Okay. What about others? Hers is saying Google search. Manish told book. YouTube comments, nice. Krishna saying names. Okay. Any other example of unstructured data? Wikipedia info. Okay. Nice. News. So whatever I'm getting about text. Yes, very nice example, Lisa. Media files. Multimedia. Very good. Data from IoT sensors. Data from IoT sensors, I think, yes, text data. Can you please repeat the question? My question was simple. Give me some example of unstructured data. The data that we can't put into rows and columns. Emails. Okay. Many people are saying emails. Emails is also good. Social media comments. List of apps. Look, list of apps you can put. XML. Very good. Images, JSON, logs. Right. Okay. There are a lot of things over here. So, if you talk about multimedia file like images, audio, video, PDFs, right? And there are many more examples like text data and all. So these are the things that we can't put into rows and columns. That is a form of unstructured data. Now, when we have to work on an unstructured data, we use deep learning techniques. Now, if we talk about images, like of classifying what type of image it is a dog's image or it is a cat's image. Audio, who is speaking? Now, if I'm going to play an audio clip of any song, you will identify the singer. Even if the song is new, but the voice of the singer, with the help of voice of the singer, you will identify, okay, this is the singer. Right? In video, right? Video, what exactly is going on, who is the actor. Those who are watching Netflix, you might have seen this thing. If any scene is going on, you can see the actor's name over there, which actors are present in the scene. PDF, totally unstructured, right? Now, why we need all these things? Now, to differentiate between the objects and all the images, the audio, what we need to mimic human brain. We need to make human brain. Okay, what is a brain made up of? What is your brain made up of? Don't tell me about your friends. Tell me about yourself. Yes, exactly, Nirmal. Neurons. Our brain is made up of neurons. So there is a neural network inside our brain. There is a neural network inside our brain, and when we try to create it artificially, that becomes artificial neural network. Artificial neural network, in short, we call it as ANN. ANN. I'll come to that topic in a second. ANN. Okay. Now, when we are talking about neural network, let's say Neural networks are also of many types. Okay, let me just fix the neural networks are of many types. What are the types? Now, base of all the neural network is going to be, guys, ANN, artificial neural network. Then we have CNN, convolutional neural network. Then we have RNN, recurrent neural network. ANN we use when, let's suppose, you have simple classification problem, like simple image classification on the less quality image, or if you are working on any regression problem, that time you will be using ANN. CNN can be used for multiple purposes. When you have to create a model to classify like high definition images and all in the real time, that time we'll be using CNN. CNN stands for convolutional neural network. Then we have RNN. RNN stands for recurrent neural network. Now it is getting used at many places, and if you talk about RNN, RNN is getting used for, let's say, stock price prediction, right? Anything that is related to time. Like for the time series data, we use RNN. So recurrent means what? It will try to keep the knowledge of the previous event, like what happened in the past, what is changing in the past. Okay, so based on that, it will try to predict the future event. Then we have text prediction also, guys. That is also we can do with RNN. Text prediction means what? Let's suppose you're solving a problem where you have to predict what is going to be the next text. Okay, if I have written 5 words, what is going to be the next one? Now this thing you might have seen in Google search. Okay, Google is also predicting what you want to type next. Okay, let me show you the simple example. Very simple example. I'll open Google. Here I'm going to type, let's say, Amitabh Bachchan. I just type Amit. I'm getting it. Amit Shah. Amitabh Bachchan age. Amit University. Okay, all these things I'm getting. Now let's say I'm going to search for Arijit. I will type ARI. Now I'm getting Arijit Singh over here. So these are nothing but the predictions. Okay, predictions over here. Let's come back over here. So anything with respect to time or text prediction, we use RNN. Okay, RNN basically comes with two more things. First one is LSTM, that is long short-term memory, and GRE. So those are the different concepts. So today we are going to focus over here on ANN. That is going to be base of what? Yes, GAN is also there. So generally we are using only this thing as of now. GAN is going to be discussed, I think, when you will be talking, starting with that thing. Yes, GAN also we can put over here. GAN. Generative Adversarial Network. LSTM is here. LSTM and GRU we use over here. Okay. What is the concept of transformer? Okay. Fine. So today's focus is going to be on ANN. ANN stands for artificial neural network. Artificial neural network. Okay. Now, when you're going to see a neural network, basically, neural network is gonna look like this. Okay, I'm not saying physically, but graphically people used to create the neural network like this. So where all the neurons, so each dot is nothing but a circle is a neuron, and all the neurons are connected to all the neurons of next layer, and all the neurons of the next layer will be connected with all the neurons of the previous layer. So this type of connections we will be having, right? Now this is the neural network where we are having, let's say we have input features, input layer, we have hidden layer, we have output layer. What are all these things we'll discuss, okay? But what exactly a single neuron is? If I'm going to talk about this particular neuron, what exactly this neuron is? Let me change that. What exactly this neuron is? What is happening behind the scene? Let's try to understand. So this single unit of the neuron, we call it as perceptron. We'll try to understand the concept of perceptron and how the calculations are done in a neural network. Okay. Perceptron. Perceptron is nothing but the single unit of a neuron. Network. Now, let's say we are going to have, I'm talking about this particular thing, a single unit. Let's say single unit I'm going to draw here like this. This is the perceptron, the single unit. Alright. Now what exactly the perceptron is going to receive? It is going to receive different inputs. Alright. Let's say I1, I2, I3. Okay, 3 inputs as of now I'm just considering. And based on the inputs, whatever the input you have given, it is going to give you one output. Okay. Now this output could be the final output, or this output could be the output going to be given to the next neuron. Okay. Fine. Now how things are working over here, there will be two things over here. We are going to divide it into two parts. Like actually it is not divided, but I'm just dividing them. Now whatever the inputs we are giving, let me arrange it properly. Just a second, let me arrange all the things properly. Input 1. All the inputs are going to be assigned with some weights. Let's say weight 1, weight 2, weight 3. And here what we will be having nothing but the summation of inputs and weights. And let's say the summation that you have taken, let's say this summation of inputs and weights I am going to consider as x. Now this x is going to get passed through one function fx, and this function we are going to call it as activation function. Now what is activation function? Activation functions are nothing but, you can say, decision maker of a particular. Now how the calculations are going to be done, let's try to understand. So we got the things like this is how all the things will get calculated, and we'll see how the calculations are going to be. Now apart from inputs and weights and like summation of input, weights and all, we have one more thing that can be added by the model. We call it as bias. Yes. Just a second. Bias. Just a second. Now weights you have, whatever the bias you have, these things are going to be added by the model. You don't need to add. So weights will be taken by the model, bias will be taken by the model. Now what is bias? Bias is going to be a particular number that is going to be used to balance the things over there. Alright. How the calculations are going to be done, we are going to check. Okay, we have seen one thing. Okay, now we'll see how the calculations are going to be done accordingly. So first of all, what I told you, we'll be having the summation of inputs and weights. How the things will get calculated, it's going to be nothing but I1 into W1 plus I2 into W2 plus I3 into W3. Then in the end we'll be having the bias. So once your summation is done, let's say this is your summation, and summation that you are taking it as X. Okay, this is your summation of input weights that you are storing in X. Now it is going to get passed through one activation function. So as of now, I am taking example of a function that you may know, sigmoid. Let's say as of now we are having sigmoid function as activation function, and there are different activation functions that we will be explaining. So what sigmoid function is going to do? Do anyone remember the formula sigmoid? 1 by anyone remember formula of sigmoid? One by 1 plus anyone? Can you put the last one? Sigmoid, I think you have gone through this function a lot of time. Not alpha. That is not alpha. Yes, very good. Rudra. Yes, very good, Rudra. Exponential of inverse x. Exponential of inverse x. So x that you are passing over here, it is getting used over here. And what this particular function do? It returns a value between 0 to 1. A probabilistic 0 to 1. Like sigmoid, we have other activation functions also that we are going to see. As of now, let's consider like this is how the calculation will get done in each particular network. And every layer that you will be having some activation function. Let's say one activation function is rate. This is sigmoid. Only on input layer you are not going to have activation function. Apart from input layer, all the layers you will be having. Now what are the layers we will discuss. Okay. Let's start with a problem. That problem that we are going to discuss is going to be considered as the hello world of deep learning. Okay. I'm just going to open my notebook. Not notebook, on Colab only. I will be sharing the link with you. Just a second. Alright. The same I'll do like this over here. Fine. Okay, I am getting the right answers in the chat. Now, this is the image, and if we talk about the image is made up of nothing but pixels. Just change it to this. Image image is made up of pixels. Now, if you talk about pixel of one color channel, let's say we are having a black and white image. We are having one black and white image. So color channel will be one. So that channel we call it as grayscale. Let's say this is a grayscale image. So here the value for grayscale image will vary up to 0 to 255. 0 to 255 for black and white. So only black or white color you will be having, or the shade of black and white. So here the same we are calling it as grayscale. Now where 3 is not there, nothing is there, blank is there, we will be assigning 0. It will be 0 over there. Alright, we will be having 0 everywhere. Okay, I'll do it quickly. Alright, now the images, the pixels that having the value of 3, any value of 3 it is having. So what it is going to have, it is going to have a number between 0 to 255. Let's say somewhat we are having it over here. So let's say we are having 150. Randomly I'm putting a number. A little thing is over there. Let's say it is 60. Here it is 80. Let's say 110, 125, 60, 210, 205. Here it is 0, here it is 0. Here let's say we are having 190, 50, 90, 120. Randomly I'm just giving some numbers. Here let's say we have 220, 195, 230, little bit, let's say 40, here 90, 95, 30. Here we have something. Now let's say here we have 70, 20. Now what you can see, wherever you are having some value over here, if I'm going to take this thing like this, let me change the color. Just change my pen color. If you are going to see, this is how the values are going. This is how the values are going. Now based on this value only we'll try to understand what exactly the pattern here we are having. But again, we are not going to give this particular image directly. First of all, event need to get changed into the vectors. What we have got, the array, right? Array. We need to convert the image data into a numerical data based on the pixel values. Color channel value. If I will say pixel value, it is not true. Color channel value. If you are going to have 3 color channels, guys, you will be having, let's say 3. In colorful image, we have 3 color channels: R, G, B. When we'll talk about CNN, that time we'll discuss RGB. 3 color channels will be having. Now we got this particular image, but just think, when you are talking about thousands of images, or you are having millions of images, just a second, just give me a minute.
आवाज की रोगनी रिकॉर्ड था
Okay, sorry about that, guys. Now, when we train a model, we are not going to train the model with 10, 50 or 1000 images. We will be training the model with thousands of images, maybe 10,000, 20,000, or it may be in millions. So a simple example I'll tell you. On the traffic signal, what you have, that helmet detection system is working. If you're not wearing the helmet, your picture will get clicked. No one is watching you over there. Who is watching? Like, it is not getting monitored by a human. It is getting monitored by a model. Model that has been trained on have images of people wearing helmet and not wearing the helmet from all angles. So it is trying to detect. We are using the different technique over there, that is computer vision, but the base of computer vision comes from here only, neural network. So the images that we are having, it is going to be in model will get millions of images to get. Now, if traffic police is using that particular model on the, so they have to be very much confident about those models. How they will get confident? If that model has been trained on vast amount of it, the model has a clear understanding between a person wearing the helmet or not wearing the helmet. Either it is a bike only. Now, let's suppose a guy is just crossing the signal by a bicycle and it has clicked the image. No, right? It will not happen. If a buffalo is crossing the road, will buffalo get the challan? No, right? Only people riding bike and scooty will get the challan. And same thing is for that thing as well. That we have seat belt detection. That is also there. If you're not wearing the seat belt, it will also get detected. All these things we are able to do with the help of deep learning. Now, when we are training the model on millions of images, these numbers that you can see, like 110, 125, 200, this becomes a quite large number. Large number. What we used to do over here, the pixel value that you have, 0 to 255, what is the highest value? 255. We used to divide it by 255. That means the entire array will get divided by 255. Why we are dividing with 255? What will happen if we are going to divide with 255? Anyone? What you will get? Binary array? Not binary array. Guys, let me tell you something. Let me ask you a simple question. Let's suppose you have a matrix. You have a matrix. Let me just remove the things. Let me create it from scratch. You have a matrix 3 by 3. You are having the value 1, 5, 10, 11, 15, 16, let's say 19, 20. The range is 1 to 20, and if I'm going to divide this entire array with 20, what will happen? Okay, very good answer. The perfect answer that I was expecting. I got it from Rohan. Nirmal also. Not the same number, guys. Not the same number. If you have this range 0 to 255, and if you are going to divide the entire array with the highest number, so actually you are going to get a normalized array. So here the values are going to get compressed between 0 to 1. All the pixel value will get compressed between 0 to 1. Yes, exactly, 0 to 1. Why we are normalizing it? So that when you are going to normalize that training data, the array and all, so you are giving less numbers to them, not big numbers. Now here, two things will happen. The first thing, training will be faster and your computation cost will be low. Two major things are there. Alright, what is going to be our next step? Now this is for all the images, guys. This will apply for all the images. Whatever the thousands of images I have on the data set, it will get applied on all the images. Once it is done, what we are going to do, we are going to perform flattening. Flattening of the array. Flattening means what? As of now, you have a 2D data, 2D image you have, like 2D array you have. This is the 2D array. We will convert into in 1D array. 1D array. Okay, so the data set that we will be using, the size of the like pixel image will be 28 by 28 pixel image. Okay, we have 28 by 28 pixel image. Now this particular array image is going to get converted into a one-dimensional array. One-dimensional array, like this. Okay. Now, how many, like what will be the length of this particular array? When it was 2D, it was 28 by 28. It is 2D. But when you are going to convert it into an 1D, what will be the size of this array? Very good. I am getting one answer, that is n into m. Very good. I was asking for the answer. It is 1, 2, 3, 4. So you will be getting till 784. How 784? Simple answer, guys. 28 into 20 is nothing but not able to write over here. I'm going out of the box. Just a second. Yes, right answers, everyone. 28 into 28, that is 780. Perfect. Now this is going to happen to each and every image, and you will be having one data set that is having, let's say, 1 to n number of rows. 1 to n number of rows of same size, like this. Okay, and whatever you have over here, this is going to be considered as your input feature. Let's say this is going to be input 1, input 2, input 3, input 4 till what input? Input 784. So 784 input features you will be having. Alright, now how exactly it is going to be taken as the layer, we'll see how exactly it will be taken as the layer. Let me come back over here. Yes. So we will be talking about this particular project in two parts. Two parts means what? We'll try to train the model in 2 times, or you can train in multiple times also. First of all, we'll have a simple architecture, one input layer and output layer, directly input and output. So how it will look like, let me tell you. You have input layer, and you have output layer. Okay. So guys, input layer is going to have total 784. Okay, so how it will be? Total 784. Let me just take it over here. Yes. So you have input 1, input 2 till input 784. Input 784. Now how many layers, so neurons will be having in the output layer? 10. Why 10? What is the number of classes? If I am going to talk about the numbers, it will be from 0 to 9. 0 to 9, that is total 10 classes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here what we will be having, we are going to see all the neurons are going to be connected. All the inputs will be given to all the neurons of the output layer. Okay. So this is how the connections you are going to see. You are giving all the inputs to all the neurons. All the inputs will be received by all the neurons. Here also. I won't be able to join all the things, but I hope you can understand. So you are passing all the inputs to all the neurons. So what do I mean to say? Every neuron is going to get total 784 inputs. Yes, we can add the intermediate layers also, that we are going to discuss, Anurag. So as of now, I'm just taking it simple. In between, we can add layers. But we are just talking about this particular concept where we are not having any hidden layer. So this is how the connections are going to be built. Right? Now, I won't be able to connect all the dots, but I hope you can understand how the things are getting. Now, you have given the inputs, and all the inputs will be assigned with some weights, weight 1, weight 2 and all. And the output layer, on output layer, you are going to have one activation function. Let's say we have sigmoid. Okay? Repeat again. Okay. I'm just going to take from here. I hope this thing was clear. So what we are doing, we are taking the image to array. We are converting into array. But the thing is, guys, the data set that we are going to use, we will be having the array form of the images. We will be directly using the array, but I will plot and I will show you how basically the image will look like. Okay. So we have a 2D array. 2D array is going to have the pixel value from 0 to 255. 0 to 55. We are going to normalize the array by dividing it with the highest value, 255. So when you are going to normalize, what you will get? The value between 0 and 1. So all this array will get normalized. We'll see all the things in code also. Now the next step is going to be flattening. Flattening is what? Converting 2D array to 1D array. So if you're going to convert 2D array, let's say this particular array that we have, this particular array represents 3. So you will be having one more thing over here. Let's say you have a column for label. Okay, label. Let's say the label is 3. Then you have 4. Then you have what? 5, 6, and so on. So this is how you will be having all the things. I am just going to show you in the form of table so that you can clearly understand what exactly the things are going to be. So this particular data from input 1 to input 784 is going to be considered as the X, and this is going to be considered as Y. I hope you remember this, X and Y. Fine. Now, so whatever the values we'll be having, we'll be after converting all these things, we'll be creating the model. In model, we have to add the layers. We'll be adding the layers, layer by layer. So as of now, we are going to see this particular simple architecture where we are going to have a input layer and only one layer, that is output layer. Input layer will have total 784 inputs. Okay, input shape you can say. Output is nothing but 10 neurons, so output shape is 10. Now, here all the inputs are going to be assigned with some weights, guys. Okay, and on the output layer, not in the input layer. In input layer, you are not going to add any what we can say. You are not going to add any activation function. On output layer, you will be adding one activation. What are all the activation functions that we can use? I will be letting you know. But as of now, just consider sigmoid is getting. How the thing will work? So let's say you are passing the image of 3. Now this 3 image will get converted, get normalized, get converted into an array. It will get normalized and then it will be given over here for this particular model. And this learning will go like this. The values, whatever the values you have in each particular inputs, will be given to all the neurons in the output layer. And weights are going to be, guys, different for all the numbers. Whatever the images that you are passing, weights will be different. Now, based on the different weights, each particular model, each particular neuron in the output layer will be having different value for a given image. Let's say here what we are going to do, we are assuming that the data set that we have, it is having 0 to 9 in this particular order. 0 to 9, the value 0 to 9. So let's say this first particular neuron is for 0, second is for 1, 2, 3, 4, 5, 6, 7, 8 and 9. When you are passing the value, you will be having some calculations, the summation of inputs, weights and bias, and it will get passed through the activation function sigmoid. What sigmoid return? A value between 0 to 9. Now let's say here for 0, this neuron is saying 0.2. That means it is saying 0.2, that is 20% I am sure this number is 0. Then here let's say we have 0.21. I am 21% sure this number is 1. Here let's say it's saying 0.32. I am 32% sure this number is 2. Here it will say, let's say 0.96. I am 96% sure this number is 3. Let's say this is saying 0.47. I am 47% sure this number is 4. 0.41. I am 41% sure this number is 5. Similarly, all the neurons will be having some value. So we are considering it as an array. This is the input array that you have. And based on the input array, you will be getting for a single image, you will be getting one output array like this. In output array, what we are going to do, we are going to find out the index of the highest value element. Index of the highest value. Let me just take it out. How we are going to find the index? We have one particular function, np.argmin. NumPy, we have argmin function that will give you the index of the what we can say highest value element. So when we are going to pass, let's say 4, this time 4 is going to receive the highest number. If I am going to give 5, 5 will receive the highest number. Based on that, we'll try to understand what exactly the number is that is entered by the user or that is given by the user. Right? Let's come to the notebook. I am going to share this notebook with you. Let me just check few things over here. Fine. I am sharing this notebook with you. Here in the chat I will be sharing with you guys. Okay, notebook link is shared. What you can do, I'm repeating again, I have given you the viewer access. What you need to do, you can click on file. You have two options, either you can save a copy and write, or if you want to download, you can download and keep it as a notebook, IPYNB. So simply I'm going to connect. And in Google Colab, you don't need to install TensorFlow. Now, what is TensorFlow? First of all, what is TensorFlow? As of now, we are doing deep learning project. For machine learning, you have used one library. You can also call it as a framework, scikit-learn, right? Now, in deep learning, we have a framework. We have multiple frameworks in the market. Two very famous frameworks are getting used as of now: TensorFlow and PyTorch. TensorFlow was developed by Google. TensorFlow was developed by Google. It is a deep learning framework. In this framework, we have lot of modules that will help us to create layers, that will help us to add functionalities like cost function, loss function, all the things. Then what we have one, on other hand, we have one more framework called PyTorch. PyTorch is basically was developed by Facebook. Now it's Meta. Meta, I hope you know Meta. Facebook become Meta now. So Meta, like all these are product of Meta only. So here we are going to use TensorFlow. TensorFlow is very easy to use. I'm not saying PyTorch is not easy to use. It is also easy to use. But we'll be exploring TensorFlow first. So you need to install TensorFlow, but in Google Colab, if you are running it offline, you will need to install TensorFlow. But here in Colab, we don't need to install it. It will be there. I'm just importing all the things. What about Keras? Okay. In TensorFlow, we have one module called Keras. Now, Keras is going to be the module that is going to contain the functionalities to create the layers. It will help you to add the layers in your neural network. And not only that, Keras also have data sets. Okay. What are the different data sets Keras have? As of now, we are using MNIST. I will be talking about a little about this Keras data set, right? Keras data set. So we can simply go to official website keras.io. As of now, guys, we are using this particular data set. Similarly, for practice, you have Cypher 10, Cypher 100 different images. Some text classification data, review sentiment, IMDb review, California housing, Boston housing price, MNIST person data. So these are the different small data sets that we have. Okay. As of now, I'm just using a inbuilt data set that we have in Keras that we can directly import or download using Keras only. And this data set that we have is going to contain 60,000 images, 60,000 rows, you can say, or images of 28 by 28 grayscale pixels, right? Grayscale pixels of 10 rows. Grayscale images. Grayscale images, you can say black and white. Okay, 60,000 training data. Okay, train set. Test set is going to be about 10,000 images. So 60,000 images to train the model and 10,000 images will be using to test the model. Okay, and you can explore the things like how you can download. You will be getting the documentation over here also. Let's come back over here. So here I have imported NumPy, TensorFlow. From TensorFlow I have imported Keras, Matplotlib and Sequon, for plotting and all. Here what we are doing, we are creating the train set and test set. Now the same thing you might have seen over here on this particular website. Okay. So we are creating the train set, we are creating the test set, from where keras.dataset.mnist load data. So data will get loaded over here. Now you can see it got downloaded. Okay, and this is the link over here. It got downloaded. What is the length of xtrain? We have 60,000. Xtest, we have 10,000. Now if you are going to see the shape, 60,000 image array, of the size 28 by 20. 2D, we have 2D images, right? Shape, if you're going to see the shape of the first row is 28 by 28. What actually you have in the first row? Image array. You have image array and the array looks like this. So actually this is 5. Actually this is the, like in the first row you have the image of 5. What it is showing? ND array. But when you are going to click on show data, you will see what exactly is there behind the scene. You have numbers from 0 to 255 that we have discussed over here, if you remember, just 0 to 255. Now what we will be doing after this, first of all, let's see what exactly we are having in the train data. So here we are iterating over the range of 10 and we are going to see the first 10 array images using matso. So plt.matso is used to display the matrix. So what exactly we got, guys, over here? I'm just going to reduce some size. So we have 5, 0, 4, the first 10 images, 4, 1, 9, 2, 1, 3, 4. Okay. Now for that X, what we have Y also. What are the first 10 Y? Here it is. So these are nothing but the labels. These are the independent data and these are the label, dependent data, target. Now what we are going to do, we are going to simply divide the entire image, the image array that we have with 255 that I have shown you over here. What we will be doing, we'll be dividing it by 255 to get it normalized. We'll see after normalizing what it will. What is the, you can see now, the numbers that you have, previously it was 0 to 255, 200, you can see over here. Let me just go above a bit. Here we were having big numbers, 253, 250, 182, 0 and all were there. But now we have got the values normalized, compressed between 0 to 1. That will become little bit, lightweight, we can say. So as of now, we are having the shape like this. Dimension is 3. We are going to perform flattening. Now flattening can be performed in two different ways. We can directly use function or we can do it manually. I am going to show you both in this way. The first thing that we'll do it manually. Manually means what? Here we are changing the shape using the reshape function. As we know, it is considered as an array. So shape, we are giving the length of that particular data set, that is 60,000, and 28 into 28, that is 784. The same thing we'll be doing with test data. Here we have stored the extend flatten and xtest flatten here to check the shape. Now we have got it in the proper form. 60,000 rows and 784 input features. 784 input features, and now it looks like this. Okay, now you can see it is now 1D array. Fine, now here comes our model. We'll try to create the model, we'll try to train the model. So here, as I told you over here, first of all, we are going to discuss only this thing, a single level architecture, one input layer and one output layer. After that, we are also going to see adding multiple things. So we are adding keras.tens. So first of all, we have created the model. From the keras, we are taking sequential. We are creating sequential model. Inside that model, we are using keras.layers. Tens 10. That means 10 neurons we want. So here this is about the output layer, and for input layer we are giving the input shape over here. And what activation function will be used? Sigmoid. So we have created one layer which is going to have input shape of 784 and 10 output, 10 neurons in the output. Once your model is created, you need to compile the model. Compile the model means what? Adding the optimizer, loss function and matrix. Optimizer is going to be nothing but it is going to be responsible for changing the weights and biases in your model. Loss function will help you to know about like how well your model is performing. As of now, we are in multi-class classification problem. For multi-class classification problem, we use sparse categorical cross control. If you are solving any binary classification problem like cat and dog classification, that time you are going to use uh, binary cross entropy. Okay, one question from Darshan. Before flattening the data, there were 60,000 rows, and what is 28 into 28? 28 into 28 is nothing but this particular image size. This the image that you can see. Now you can see 0 to 25, so it is total 28. We can't see over here, but it's 28. The shape of this particular image. It is 28 by 28 pixel image. Okay, that we have in the form of array. Like this type of array. Okay, Darshan? Yes, exactly. Now we have flattened it and we have made it 784. Matrix, as we are using a classification, we are doing a classification project, so matrix is going to be accuracy only. Fit. Here now we are going to ask the model to get trained with the X and Y, and here we have epochs. What is epochs right now? And here I have kept 5. The epoch numbers can be changed. You can keep 10, you can keep 20, you can keep 100 also. What is epochs? Epochs is nothing but the number of iteration the model will take to train itself. So 5 means what? 5 iteration. 5 times the model will get trained. Now here you will notice one thing. After each epoch, your accuracy is getting more. You're getting more accuracy. And after 5 epoch, what we have got? You have got 92% of the accuracy. Now this accuracy is on the trained data. It is on the trained data. Number of cycles, yes, exactly, number of cycles. Now here we are going to evaluate the model with the test data, and what we have got, if you are going to see, it is 91%. So 92% is the train accuracy, 91% the test accuracy. We have balanced it. But if 91% is the data, like the accuracy for trained data, that means we are having 9% of the errors, right? How to find out the errors? What we'll do, we will ask the model to predict X test. Predictions are going to be an array of 10 values. Now what do I mean? This particular array you're getting this particular array. Once you got this array, what you need to do, you need to find out what is the maximum value and at what index it is. So if you're going to see what exactly it is, X test, the first value that we have, I'm taking only index 0. Index 0, it is saying 7. What is the maximum value in this array? 99% surety the model is having. But what exactly is the index? Argmax. 7. Okay, I think I have done one thing wrong, guys, here. Sorry, this is not mean. This is max. We use max to, just a second. We use argmax to take the maximum value. Fine. We got it over here, the maximum value. Now what we'll do? We'll try to take all the argmax, all the index of the highest value from in the entire array, and we'll store it in Y predictor levels. So you got to store what are the first 10 values. The first 10 values are follows like this: 7, 2, 1, 0, 4, 1, 4, 9, 6, 9. All right. Let's see the result. Okay, now what we can see, we have 7. Let me zoom out a bit so that we can see the entire thing. 7, 2, 1, 0, 4, 1, 4, 9, 6, 9. Now first 10 predictions are true, but where we are getting the wrong prediction? where our model is lagging. So that will come to know from confusion matrix. Now confusion matrix we have already seen from scikit-learn.matrix, but TensorFlow itself it has its own confusion matrix in math module. So we are giving the label that is the actual data and the predictions that is the predicted data. So this is the confusion matrix and better to plot it. When we plotted it, what we are getting? 0 got predicted as 0, 59 times, but 0 is also getting predicted as other numbers also, you can see. What are the major errors? We look over here. 2 is getting predicted as 37. 2 is getting predicted as 37. Sorry, no, 2 is getting predicted as 8. Sorry, 2 is getting predicted as 8. How many times? 37 times. 4 is getting predicted as 9, 30 times. 5 is also getting predicted as 8, 31 times. 5 is getting predicted as what? 3, 37 times. Now these are the high number of the errors. 9 is also getting predicted as. What we'll try to do after break, guys, after break we will try to add more layers over here. After more layers over here, and we'll try to check what exactly the improvement we will be getting. Okay, clear till here, everyone? I will be talking about the epochs and all after the break. Let it be till here. Are you able to understand this part? We can increase the epochs, no problem, but we'll see. I'll discuss one more thing about the epochs. Why we can't. You can go till 10 epochs, 20 epochs also. You can go to 100 or 500 also. But after some time, after some epochs reaching at some extent, your model performance start degrading. For that, we have some different technique that we'll be talking about. Regularization technique we have. We'll be talking about it. LinkedIn, after break I'll give you my LinkedIn, guys. Okay. Sir, can you Sajam detects music? I don't have any idea about this, Krishna. I need to check out. Okay, LinkedIn, if you want, I'm sharing my LinkedIn. Just a second.
Yes.
All right.
Thanks.
All right. So I've given my LinkedIn URL. So you can connect with me, Professor.